Guys, welcome to my YouTube channel. Today I'm going to be teaching you guys acids and base. So I will make sure that I explain this topic thoroughly so that all the grade 12 learners will understand this topic much better. Guys, if you have any comments, please feel free to comment in the comment section. And guys, please don't forget to click the notification button for more content and also to subscribe. Guys, please subscribe to my YouTube channel so that you can become part of the family. All right, acid and base. All right. Now, what we know is that acids release H3O plus ions / H plus ions, while bases release OH minus, right? Ends there. Now, typical strong acids, you have your HCl, for instance. It's a strong acid, while the likes of your carbonic acids are weak acids. All right. Now, what are polyprotic acid? Poly comes from many. Protic comes from the proton H plus. Polyprotic acids comes from this proton. So polyprotic acids can donate more than one proton or one H plus. For instance, we have H2SO4. H2SO4, it can donate one hydrogen to become HSO4 minus. And this HSO4 minus can further donate another hydrogen to become SO4 2 minus. That is why we call them polyprotic acid, because they can donate more. Other examples, you can have your H3PO4, phosphoric acid. Now, when an acid donate and H plus, a conjugate base is formed. Now, in this equation, this is a conjugate base. This is a conjugate base. Now, let's say, for instance, e.g., HCl. If it donates hydrogen plus Cl minus. Now, this is a conjugate conjugate base. All right. Now, what are ampholites? Ampholites. Now, ampholites can be both acid or base. Now, what are those? Your typical example will be SO4 minus. Now, this ampholite can either gain a proton, H plus, or lose. So if it gains, say for instance, if we have this situation, we will have H2SO4, or if it further loses another proton, we will have something of this sort. So that's why we call them ampholites. Now, when salt, another observation with acid and bases, that when you add an acid plus a base, you will get water plus salt. All right. For an example, and when the salt dissolves, it forms ions. All right, for instance, sodium chloride will dissolve in water to form plus chloride ions. And all these are aqueous, you can say solid. It's okay. Now, the so-called indicators. Indicators. Now, indicators are also chemicals. Now, with indicators, a typical example, we have bromothymol blue, which changes from blue to yellow. If deep in acid. Now, there's a lot of indicators. I won't talk much about indicators, but indicators are actually chemicals themselves. Now, during titration, there's going to be a lot of titration questions. Now, during titration, what we know is that the number of moles normally do not change. So we are expecting to use these formulas a lot when we are doing titration calculations. And what we know is those proportions, they hold. Now, let us look at the ionization of acid. Now, the ionization of acid takes place in, as follows. Okay. Now, what we know is that your acids plus water. Now, if you put acid in water, you will get the following reversible reaction. Okay, plus A minus aqueous. Right. What is the Kc or the K of acid in this matter? We will have the following. If you don't agree, please do not hesitate to comment. You can put a comment section. You can put a question on the comment section if you do not understand. All right. Now, with base ionization, we have the following. This will be your conjugate acid. Right. All right. Now your KB will be these are your products. Okay. 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 Now, Moving right along, we know that if Ka or Kb is greater than 1, that's a strong acid or base. That means if the Kc is greater than 1, it means the ionization is very strong. Means there's more product formed during the ionization. All right. Now, what happened to the ionization of water? Now, H2O can also ionize. I mean, you add more water, you will get the following. Okay. Okay. Now, the Kw or the K ionization of water will be, we only have the products that are in aqueous solution. So we'll have following. Note that the equation above is balanced, guys. It is balanced. Over 1. And typically, this will be equal to always, however, at room temperature at 25 degrees Celsius. Okay. Only if those conditions are met. If they are not, then we don't get it. All right. Now, at neutral, the concentration of H3O plus is 10 to the power 7. And it's equals to the concentration of OH minus. All right. Now, there's a formula to find pH. Now, to get pH, you have to use the log of H3O plus. All right. Now, there's another concept that we're going to learn later. It's a standard solution. Now, a standard solution has a known concentration. Okay, and which remain constant for a period of time. Okay. Now moving right along, what we know is that I think we have done is acid ionization. Now, I think that is about it. think that is about it now. Guys, thank you so much for listening to my lesson. And if you have any question, please feel free to head into the comment section, put your questions in there. And also, if you have done a question paper and you feel like you did not understand, please feel free to put it in the comment section. Request my email. I will put it up if you want it, so that you can send me your question and I will help you guys. Guys, please don't forget to subscribe and click the notification button for more content. I'm up for the next one. Thanks.